Good day, guys. So this is an upgrade or a build-up from our first lesson on exponential relationships. Today we are going to focus on the second part of the lesson, which is the most important to me, because almost every college student should know or should be able to navigate through the first concept we treated, which was about how to build up or how to make an equation out of a relationship given in a word problem. So whenever you have a situation like that, you know your final value is is what is here. That is, the first one, the first variable here. So y is equal to, or a is equal to anything at all. B is equal to. Then the first one you see here is your initial value. Initial value then multiplied by the amount by which your initial value will be multiplied by in a specific interval. Then your exponent will be your interval. Very easy. And then I told you that sometimes your multiplier, the number that's multiplying, sometimes will be given in a percentage. Okay. Now in these cases, you just make sure that you rather multiply it by, you don't multiply by the percentage. You apply your knowledge from percent increase or decrease in values. And you know that whenever a value is increased by a percent, you just add 1 to that percentage. So if it's 5%, you add 1 plus 5%. That's 1 plus 5 to 100. That's 1 plus 0.05. You have 1.05. If it is 200%, it's 1 plus what? 2. That will give you multiply it by 3. So depending on which percentage you are given, you know what to multiply by. That's what we treated in the last session. And then building up from that. Now, sometimes you'll be given a question where, after giving you a scenario or a word problem and then giving you your initial value, the number you're multiplying by, and then the interval, you are asked to model the relationship in another rate, different from the period or different from the interval that was given in your problem. For example, let's say you have the price of this commodity, okay, and the price is, let's say, $1,000, okay, so 10 to the power $3, okay, and then this is the initial value, right? The value increases by 10%, okay, so 10% increase. There's 10% increase for every 10 years. That's decade, right? So let's do it for every 10 years. Okay, 10 years. So for every decade, let's do this for every decade. I'm coming. For 1 decade. Okay, so 1 decade. This is the question. So when you're asked to model this, we all know that it will be something like this. So final value f in decade, okay, will be equal to, okay, we know that it will be 10 to the power 3, okay, multiplied by 1.1, okay, 1.1, and this to the power 1 in the decade, okay. Now this is the normal one where you're asked to model the relationship for the decade. But what if the question is changed? Let's say you're asked to model the relationship or the final value of this commodity after 5 years, or after 3 years, or after 26 years, or after 27 years. How do you do it? There's an easy way to navigate through that. Now, whenever you find yourself in this situation, it is very simple. You just find a relationship. So you find a relationship R between the rate 1 and rate 2. That's the period 1 and period 2. So let me do it in rate period. So rate period 1 and rate period 2. So the rate period given in your question and the rate period in which you are being asked to find it in, you just find a relationship between them. So for example, in this case, let's say I asked to model a relationship for 25 years, okay, for 25 years. Now that's how you do it. So you know that if 1 decade, okay, you just find a relationship. Okay, so this is how you do it. 1 decade, that's 1 decade is 10 years, okay. If 1 decade is 10 years, then what would 25 years be? So this is it. And 25 years would be what? So you have 25 over 10, okay, over 10. Sorry. So let's go back and restart the work. So after, there is an easy way to just find your relationship with ease. And this is how you do it. First, you find, so your rate 1 and rate 2. So our rate 1 is, so this is our rate 1, and this is your rate 2. Okay, so your rate 1 is the decade, rate 2 is for the, so let's say rate for the decade here and rate for 25 years here is equal to, you know, the decade. Your decade is what? 10 years. So 10 over your 25 years. So 25, that one is easy. You know, it's 25. Now, what do we want to do? We want to eliminate the decade here and replace it by what? Replace it by the 20 rate for 25. Okay. So that means you are going to find the decade in terms of the 25. So it means we move the 25 to the other side of the equation. So RD will be equal to 10 over 25. That's 2 over 5 R2. Okay, 2 over 5 R25. 2 over 5 R25. And then we know this is 0.4 in 0.4 R. It means RD is 0.4 R. Or we can replace the D here, okay, by 0.4 R25. So let's say you represented your 25 by T instead of R25. So in your answer, it will be FT, okay, FT will be equal to, okay, FT will be equal to your 10 exponent 3, which won't change. So the only part of the equation that will change will be the exponent. And your 1.1 will still be there, okay. And then now your exponent here will be what? 0.4 T. Very simple. So the very important part of the solution is to look for the relationship between your first rate and your second rate, and you're done. Just replace the exponent by that. So let's take another example. For every 25, let's say I'll give you a question. For every 25 minutes, okay, for every 25 minutes, the number of inhabitants of a certain city increase by 2%, okay, by 2%, so 2%, 2% in 25 minutes. The number of inhabitants increased by 2%. Now, we're asked to find or to model or find the final equation that will give you the final number of people or the total number of people in the same city after a year. Okay, this is quite a difficult one, but we can navigate our way through it. So you first model this one. You have, let's represent 25 minutes by T. So your FT, so your final or total T value will be equal to, and then I didn't give the initial. Let's say that the population is 1 million. Okay, well now, for 1 million, you have 1 million to 10 to the power 6. Okay, and this will multiply by 1.2. That's the 2%. And this will multiply by, let's represent 25 to 25 by T, and then represent a year by Y. Okay, a year by Y. So you have to the power of 1. That's it. That's 25 minutes. Presenting T. So T here for the whole 25 minutes. So 1 here for 25 minutes. This 1.2%. Sorry, 1.2 here, 10 to the power 6 here 1. So this is for 25 minutes. How do you get it for your 1 year? Now, what do you have to do? So first of all, you just have to find a relationship between these two rates given here. So you know 25 minutes. Sorry, 25 minutes represented by T, right? So you know your T over your Y will be equal to. So it's either you convert the minutes to years or the years to minutes. So I prefer converting the years to minutes instead. Okay, so you have 25 minutes here. 25. You have to convert the year to minutes. So 1 year is, let's say, 365 days. Now, for every 365 days, you have 24 hours. So you multiply that by 24. Now, in every 24, in every hour, you have 60 minutes. Okay? And then every 60 minutes. So that's it. I think you're done. That's where you're going to reach. So 365 times 24 times 60. So 365 times 24 and times your 60. I'm not going to continue. So this should give you an idea of how our answer is going to look like. Okay, we want to find it in terms of y. So you just move y to the other side of the equation. You have 25. So fy in this case, okay, fy will be easy. 10 to the power 6 multiplying 1 point. Exponent, and the exponent is going to be all this. Exponent is going to be 25, a fraction. Numerators are 25. Denominator 365. Okay, times 24, a long one, right? 24, then times 60. Then multiply this whole expression by what? By y. This will be your exponent. So no matter how complex the problem seems, you have just one approach. Look for a relationship between the interval in your question and the interval in the model we are supposed to create. After getting the interval, that will be your exponent. You just write the same model with a different exponent and you are there. Thank you for joining this class on exponential relationships. I hope you really make the most from it. And then see you in my next lesson. Bye.